Event loop is operated by the Libuv library. During event loop's poll phase, select I/O and async CPU-bound operations are delegated to the thread pool. When an operation is added to the queue for the poll phase, Libuv checks if there is a worker thread available. If there is one, the task is immediately assigned to it for execution. If all worker threads are currently busy, the task is added to the end of the queue and will be executed by the next available worker thread. Node's main thread, responsible for executing JavaScript, is of course, as you now know, single-threaded. Its other job is to delegate I/O and async CPU-bound tasks to the event loop and consequently the thread pool. Therefore, you could say that Node.js is single-threaded when executing JavaScript, yet multi-threaded when executing I/O and async CPU-bound operations. It's also important to note that network I/O, such as reaching to the database, uses main thread that initiates network requests, but the actual I/O operation is non-blocking and handled by Libuv and the underlying operating system. This allows the main thread to continue executing other JavaScript code while the network operation is in progress. Finally, the default thread count in Node is 4, and this is on top of the main thread. This can be changed by setting an environment variable uv_threadpool_size to a number such as 8. But be wary that increasing the thread pool size over the number of physical threads in your computer's CPU or server is not advisable. Not only will that have no performance benefits whatsoever, but in fact it will degrade it because of the additional overhead related to switching between threads and coordinating them done by the operating system.